Basically a non-linear data structure. So what do you mean by a non-linear data structure? What is a non-linear data? Okay, what is a linear data structure?
The
Stacks
storage
and queues
elements
are
are
considered as
in
linear.
a straight line, while in non-linear, they're not in a straight line.
So that is one after the other sequentially we will be doing the processing in case of a linear structure. Whereas in non-linear we don't have to sequentially follow or we don't have to follow any kind of sequence. Instead we can group them and we can do the processing in a non-sequence manner. Okay. So this is the difference between your linear and non-linear. So what is a major drawback in linear? Any idea? So first tell me what are the linear data structures you have studied?
Array,
Array, then
stacks,
Linked list,
linked
Linked
list,
linked
list,
list,
stacks,
queues.
stack,
stack,
queue,
queue.
stacks,
Good.
queues, queues,
Yes, good. Mm. So these are some of the linear data structures you have studied in
and data structures when in the linear data structure.
so far. Okay.
lean.
So now, can you tell me what is the major drawback that we wanted to introduce a non-linear data structure, or what could be the major drawback? So I told you this is going to work in a sequence manner, whereas in non-linear, I won't have to worry about the sequence. I can group together and can work. So with respect to
Maybe you
complexity,
have to
what can you? Yes, yes, please.
please repeat the question.
So not able to hear you properly. Just tell me. With respect to complexity, what can you think could be a drawback of your linear data structure? What is the worst case time complexity for most of the linear data structures?
O of n.
Often, when you group your items together, you have seen few examples like binary search, sorting in your unit one, right? There you try to divide your problems into sub-problems and group together, no? So what was the time complexity you got during that time? Worst case time complexity? Anyone remember? What is this, ma'am? If you ask me question in third unit itself, I won't be able to tell you. You are asking me a question from unit one now. Hmm? Yes, Neelab, tell me. What is the time complexity for binary search, Neelab? Divya, time complexity. Yes, time complexity for binary search. Yash,
Yes, ma'am.
time complexity for binary search.
O of n, ma'am.
Binary search is O of n. What is the advantage
O
of
of n
binary
log n.
O
O
search?
of log n.
N
of
log.
N log n.
Log n. Is it O of log? Who said O of log n?
Yes, ma'am.
yes,
Who's that?
Achintya Mishra.
I'm sorry?
Achintya Mishra.
Praful ma'am.
Okay.
Ma'am,
Now,
I told O of n log n.
okay. What is the time complexity for linear search?
O of n, ma'am.
O of n. Is binary search advantageous over linear search? Yes or no? Yes. Then how can your binary search have more time compared to linear search? What is the difference that made your binary search superior to linear search?
For best case, ma'am.
For worst case only, we will always stop. Don't even think about best case. By teaching complexity itself, I told you, right? Whenever we talk about time complexity, it will be either worst case or average case. We won't even worry about best case. What is the advantage of linear search over binary search, ma'am?
Ma'am, we don't have to traverse the full list.
Yes. If you don't have to traverse the full list, will the time complexity of binary search be greater than linear search or lesser than linear search?
Lesser.
Is my question clear?
Less.
I don't have to traverse the full list in binary search. So will my time complexity be
Less.
lesser, right? So how can it be n log n? When for linear search itself, if it is n, shouldn't it be lesser than n?
Yes, ma'am. That's why it's O of log n.
Oh, log n, ma'am. Not log n.
What is the answer? So it is log n.
Yes, ma'am.
Okay. Clear? Good, Cynthia. Okay. So the answer should be log n. So this is one of the difficulty in linear data structures. Okay. Disadvantage in whether it's be linked list based implementation or array based implementation. At the worst case, most of your problems will require order of n times to execute your problem. Okay. Or in few cases, it can even go greater than n. For a linear data, when you use linear data structure to implement that problem. Okay? So this is the reason why we go for a non-linear data structure. Because in your non-linear data structure, what you used to do was you will divide your problems into sub-problems based on some kind of common similarity, and you will identify the groupings. Clear? So based on the groupings, since you are going to work further, definitely the number of time units required will be reduced to log n. Okay? Clear? Am I clear?
Yes, ma'am.
So everyone? So this is one of the reason why we go for a non-linear data structure. Even though we are it is very easier to implement all the things with a linear data structure. The reason why we are going for a non-linear data structure is the time required to execute that problem will be much reduced when you go with a non-linear data structure, and also obviously the space required as well. Okay, ma? So with this introduction, I will start to the fourth unit. Okay. So the fourth unit is basically trees. So a tree can be considered as a non-linear data structure which follows a hierarchical pattern. We have already seen, right? There will be some head, and then below that there can be some divisions. Okay. So below this subhead, I can have several divisions. Likewise, under each and every thing, I can have multiple divisions also. Okay. So based on this divisions or how it is divided, the tree will have different representations. Okay. So all those representations you will be studying, and based on how you're going to construct your tree and where exactly the tree will be used, there are several different varieties of trees. Okay. So each and every tree has its own advantage as well as disadvantage. Okay. So mostly each and every tree will be used to solve a specific problem. Okay. So this is your fourth unit. So I'll try to rush up a little bit faster for the tree, general tree and tree terminologies. Okay. So that I can finish all these things by today and I can start with binary tree tomorrow. Okay. So I told you, right? So the access time for a linked list or any linear data structure will be little bit higher. Okay? So in order to reduce the time taken or the access time required for doing a searching operation or insertion or deletion operation, the main solution is grouping data. Okay? So if we group data into some kind of common similarities, with the help of some common similarities, then we can reduce the time taken. Okay? So tree-in was one such solution for that. Okay? So basically it is a non-linear data structure. Okay? So here we represent data in a hierarchical fashion. We don't follow any consecutive or linear fashion in this. Okay? So some of the examples we have already seen are, if you see your computer, the file systems, how the file systems are maintained. So that is one set of example. And any family structure. So there will be a father under him, or I can have, say, some kind of head under him. Your father and mother can come. Okay, then I can have some kids. Okay, likewise I can group several things. Okay, so if this is a parent, these two will be children of this parent. They are siblings. So these children can have other children's. These children can have another children. Okay, so any family structure can be drawn like in a tree-based things. Similarly, your organization structure, there will be chairman. Under chairman, I can have academic or I can, this is your chancellor. If we take our structure, university structure, under chancellor, I will have academic chancellor and administration chancellor. Then, so for both these two people, VC will be there, vice chancellor will be there. Under vice chancellor, multiple groups. For ENT, there will be one director, or pro VCs will be there. Okay. So then under if I take ENT alone, I will have this dean. Then multiple departments, civil, mechanical, CSE, ECE, like that. So each and every department will have its own head. Okay. So for if I take CSE alone, it will have four years. First year, second year, third year, final year. Okay. So under each year, I can have multiple divisions. Likewise, I can keep on drawing the organizational structure in a non-linear fashion using a tree. Okay. So one of the major advantages, the worst case time will be order of log n instead of order of n. And then your tree can be implemented in several ways with the help of a linear linked list or with the help of an array, either in a recursive fashion or in an iterative fashion. Okay. So I can use both recursive and iterative fashion.